Hi all, welcome back to the another session of data structure, and agenda today is to discuss on the linked list. And first of all, I will request that you should watch this on laptop or PC because you will be not able to see that complete screen on mobile. And the audience I am expecting should have knowledge of C pointers and programming. So we will discuss what linked list consists of, what is the advantage of linked list as compared to array and singly linked list, and its applications, and debugging linked list code using this project. So let me first go through whatever the data is available on the web. Uh, let's say let me go through some points of the linked list. What the introduction is, linked lists are the best and simplest example of a dynamic data structure that uses pointer for its implementation. So I will go through this text and we will see that actual implementation in the code, and see that practically how it is implemented. So essentially linked list function as an array that can grow and shrink as needed. So array means, whenever we discuss about array, it means that similar kind of objects, and linked list have few advantages over arrays. So items can be added or removed from the middle of the list. This is one of the main advantages, and there is no need to define an initial size. So dynamically nodes can be allocated for the linked list, but there are few disadvantages as well. For example, there is no random access. It is not possible to reach the nth item in the array. For example, in the array we used to directly reach to that particular. So in this case you have to iterate through overall the items. Second, dynamic memory allocation and pointers are required, which complicates the code and increases the risk of memory leaks and segment faults. So this we will see while going through the project. And this linked list has much larger overhead over arrays, but still you will see a lot of advantage of linked list in the memory management, and we'll go through one by one. So what the linked list basically, so it consists of this kind of element. If you see in that screen, the one is the data and another is the pointer to the another one. So this is called this is the node. This is one set is called node. So right now this is a singly linked list of two nodes. The first is pointing to the another one. Okay, so let me quickly go through that some pictorial representation on this particular website. That is a good one. So this is let's say linked list. This is called this start of this first node. So first node, the pointer to the first node is called the head, and this consists of data, and next to the another node. Then this next is pointing to the another node. So this is basically the address of the node. So next is next consists the address of the next node. So what is the last node? We will have the next, because if this is the last node, so there is no further node, so it should this next value of next should contain null. Okay, so types of linked list, we have simple linked list, doubly linked list. So navigation in this basically item navigate forward only from one side to another side. So for example in stack, And doubly linked list, you have items can navigate forward and backward, means it will have the pointer both the side. And circular linked list, in this basically the last node will point to the first node, so that will be a circular one. And basic operations, there will be insertion of add an element at the beginning of the list, or deletion, delete an element at the beginning of the list, or in the middle of the list, or somewhere in that at the end of the list. Similarly for insertion, display, and search an element using the given key. The key will be here something, the contents related to the node, and delete based on the given key. So what will, for example, let's see the insertion operation. So initially that in this case, before insertion, suppose this is that one list and you are going to insert another node. So what you need to do, you need to create a node, and this had initially it was this is that after insertion, ideally this had should now point to this node, and this next should point to this one. So after insertion. So for deletion, similarly this first one should point directly to this one, so this will be deleted. So, and for navigating, this is the current one, first one, and then pointer to this next, then this way it can move. This is the navigation of the. So there are advanced operations also, like sorting, searching, those kind of things we will see in the project. Okay, so let's see the code we have, and in this particular code, what we are going to do, from the main we are going to create and insert the node. We'll call this function. Okay, so what this create and insert node does, let's go to that particular function. So in this case, there is it is creating one character array, and this is initializing the empty, and one this marks, and then node it is creating new node is a pointer to the node. Let's see what is node. Okay, so in the last presentation we discussed about that type diff, and now this is that we are discussing the another data type. So far we have discussed the data type, built-in data type, integer, character, or further data structure specific arrays. In the arrays we discussed arrays, basically similar kind of elements, whether it is a character array or some integer array. So what happens if you need a mixture of elements? So here you can see the first one is the character array, second one is the integer. So different data types. In that case you need something called struct. Okay, if you struct, and I have given just a name to this particular struct, and based on this, this is the data of this particular struct, and type diff struct my node, and this name I have given means from this to this whatever it's there will be our new data type. As last time we did, like type diff integer, unsigned integer is byte. So in this case, because struct is a well-known thing, but struct we have defined one custom structure here, and we are now defining that particular struct as one particular type node. Okay, so in this case, this node is the type. Further, this the node is a type, and this particular my node is basically element. And why my node is needed? If suppose if I remove this my node, I cannot make it because I need pointer to similar type of another object. So I need a pointer here. So in that case I cannot make pointer to this node because this is not yet defined yet. So this my node I have defined, so that's why this next is a pointer to this particular struct. And why I did type diff? Because if you don't use this type diff, then every time you have to use this struct in front of this. Means whenever you create, you have to create something like struct my node to pointer or whatever. Every time you have to use this. So to simplify this, I have done this. So in our case, the data is this and address is this. So this complete is a node. And next time, whenever we use node, so it will be a complete data type. You can see here. Okay, so if I right click and open declaration, so anyway it will show that one. So this head is pointer to the node. Initially this is the null, and the current node for traversing into that, this is null. I have defined these two as a for the file scope. Let's see what this create, the function we use there, create insert node. So we have done one temporary character, because we know that there are only two things, name and let's say student name and marks. Okay, we want to create one particular linked list for that. So node is pointer to, new node is pointer to this. So it will ask the name and scanf. We will get this name to the this temporary thing, and then we will check that similarly we will get from that marks. Okay, after that, so this will put data in this particular name and marks, and then okay, we will anyway check this debugging while doing this. The new node is create node. So what is this create node? I am passing this parameter name and marks to the create node. Let's see what is the create node. Create node, we get parameter name and marks. Then new node, malloc, using the malloc memory allocation, size of the node, whatever our node is the structure. Now we know that this it is showing comment also, so that's why it is not clearly showing that. So runtime we will see the definition, and node anyway we know the type of that. So size of the node, it will allocate this memory and typecast it to pointer to node and assign to this new node which we defined for this function scope. So note this, in this case we have seen that linked list is created by dynamical memory allocation. Correct, we have to, because we have to pass that particular pointer to another pointer for that operation. So we use this malloc, and in this case string copy, we got this st name to this let's see that string copy is right side is from and left side is to. This is that prototype. So from this to this we have copied. Then marks, simply we assign this particular marks and name we copied there from the earlier function. Now the next we will make it null, because this is our one node. It is not yet, this has just created one node, and return this particular new node to the our function from where we called it. So we will get one node here. Now we need to insert this node, this particular node. So why I have mentioned just here insert? Because in our case head is already defined as a in the file scope, and there can be multiple other options doing this insert node, that you can see different kind of code can be written. That anyway you can refer to that. Let's say you can refer to this particular link and see, you will see different kind of code, how these guys are using this. So that reference anyway you can find out, and the purpose is here to see the practically how it works. Then inserting the node, new node. Let's go to this new node. Insert the node. After create, insert the node. So first one, if not head, it means head is not yet defined, correct? Because head was null. So in the first case, what it will make head, it will make this new node is head. But if head first time when that list was empty, so it will make head as a or head or first node as a this whatever node we pass to this. Second time whenever this function will be called, then it will create current node. Next is the new node whatever we pass, and current node is becomes the new node. Okay, so what is this current node, by the way, that we will see here. Current node in the beginning is null, so current next will become the new node whatever we passed. Okay, so let's see how it is working. Okay, first time current node will become the first time when it was here, so current node will become the new node, means in the beginning. Second time current node next, first time it was first actually head, so head next will become the new node. So this way it will be inserted at that point. If you see that this particular diagram here, so first time this pointer was null, so head was this pointing to this whatever node we passed. Second time we had this particular data already, so current, and first time the current pointer will become this one. So second time current pointer next will be the whatever node we passed. So this way every time this next is null, so this way like it will keep adding another element. Let's see the actual data. Let's go to debug as local application, and just a moment. I think it was already built, and let me build it again. 0 errors, and debug as local application. Okay, it is executing. I can see the progress here. Okay, switch to the debug perspective, and let's step into. So this is the create insert node function. We have called it first, so this is the temporary step over. You will see that now it will ask for that data using the scanf. You can put, let's say, ABC. And one thing I would like to show you here, that let's enter this data, and I would like to show you that this particular name, let's say from here, if I put this name here, you'll notice that name is already ABC, and rest of the thing till the end is null because we initialize it just like this. Okay, similarly the second one, let's say whatever 34, enter, then marks also there. So this is the temporary for this particular if we go through this name and this is the marks is 34, so temporary to this particular function. So now we will pass this to create node. Let's go inside that particular function. So it will create new node, and one thing here I would like to again check. Let's see, st name. Okay, so st name, and if you abc, again abc, you can check this complete array if you want, like it is only this abc anyway. That one thing is here ffcb30. So what we can look into the registers, and in that register last time we have seen that between the stack pointer and this rbp, our stack for this particular function. So this basically from the last function it was in between that, so that's why it was. But I would like to say that this is basically some stack related address, temporary address, whatever we are passing. Now new node, let's see what is this new node comes here, and if we see this expression again here, let's say new node. Okay, so this address right now it is not showing any. This new node is this one, and within that data is this, and let's say further go to allocating that particular address. Now you see this new node address, this is something not your stack address, so this is the memory address. Okay, and in this memory address name some junk is there because we have not initialized it. You can see the junk here. So this is what I would like to say. I wanted to show you that how to debug this kind of code. So when I will string copy, what it will do, it will copy only this particular part, and then new node marks and new node next will be null. So return first node, or one node is created. Now this new node, whatever new node we have, you can see this new node is return value from there. So the 34 marks and name is abc. Then what happened? Insert to this one, because the head is still null, so it will step over, and head is basically now new node. You can check that head is the same address as the marks. From the marks you can see that same address as the 39680 new node. Okay, and its next is still null because we have only one pointer, and current node, it was earlier it was 0 because it was null, but once we go further, so this will become the latest. So current and head both are same now. Let's go further and see that it is asking whether print yes or no. So what we can say right now, no. Let's say I want to enter another data as well, and here one thing you might have noted that we are using do while. It means at least execute these instructions once before checking this particular condition. Okay, now it is doing string comparison of this whatever data character dump array we have received with yes. If it is no, so it will keep moving in this particular function. So in this particular do while loop, sorry. So let's go further. I don't want to go inside this string comparison, so let's step over, and I would like to go inside this create insert, and then let's again same thing. We have to take one node, and this time let's say I put DEF ABCD DEF and enter. Then I will take that another one also, marks, and let's say this time 67, enter. And what it does, again it will create a new node. Okay, let's it create a new node for this, and we have now new node, and the node is some this address, and it has 67, it has this DEF. Okay, then we need to insert it. So this will be now interesting because we already have the head initialized. So let's go inside that. This time it will go to this else condition. So now current node next. So what is our current node? So let's see here. Current node. Current node is this, and within that next is still null, and our new node is this 396B0. So once I execute this particular instruction, you will see that now current node, and where is our head, by the way? Let's see, our head node is 80. So 80 connected with the new node. Now still current node is old one. Okay, so now we need to change the current node to the latest one. Are you getting my point? Head node, this is the head node. Head node is the same, this one. Then this, the next of this is the new node. This new node address is this, and is the null. So let's go further. Okay, now it is a list of 2 nodes. So simply list of 2 nodes. So whereas the head node is this one, and current node is our next one. So head node is our ABC 34, or this is 67. So this is the head node address, then head node next address. The head node is last one 39680, and its next is 396B0, which is the address of our current node 396B0, and within that we can see that name is DF and the marks, and its next is 0, that is the null. So because this is the 2 node only. So similarly the third node will be also inserted. But let me see further. This time I don't want to proceed further. Okay, so it will come out of this, and here I have used this if directive, because I would like to check this bubble sort later. So that's why this code compiler will ignore. But you cannot use if diff here. If you use if diff here, then you have to use, you cannot use 0. So you have to use some identifier, valid identifier. There is some name, and then that name if it is not defined. So I could write simply if anything which is not defined. So that would be, if that, then it could be like if not defined kind of. or if deep, then use bubble sort, whatever, some identifier. Anyway, so now dump list is basically printing that, navigating through the list. So we know head is that our global file scope pointer, so we are passing the head to this. And another thing you might have noticed that we are now using some memory addresses, we are not using that temporary stack addresses. So from the heap basically we are using this. Okay, so if we dump, so let's create one another current point. This current pointer is basically for this function only, so don't confuse with the other one, because we want to navigate. So first is, let's say it is null. So while the what is this pointer? This pointer is our head pointer, but we passed from there. This, don't confuse with this. So this pointer is right now head. So unless it reads that null, it will go inside this. So current pointer will become pointer, and it will print the our first name. Okay, this is because some uninitialized characters somewhere, and by ABC and 34, and right now I'm ignoring that. No, not uninitialized, sorry, this is the mistake. Okay, sorry. Okay, here, so some typo. Okay, so let's go to next one, and then pointer will become pointer next. So this is the current pointer was our head. So now the next pointer, simply that will change to the next one. Okay, so free, this pointer is now pointer moved to next one, our second node. Okay, that is 396B0, and you see that 667, and last one is the null. So here now it is, we have to free this first pointer. If we don't do that, what will happen that because this is not a temporary memory of this particular function, this is a properly allocated memory using malloc. So that may cause the memory leak issue. So if you are not using that pointer, we have to free that pointer, and but I am assuming that I will not use this pointer after printing this. That's why I am freeing. Otherwise, we have to write separate function for delete pointer. Okay, I am just using for this purpose only, so I will free it. Secondly, pointer is still not null. It will go inside this. It will again pointer, and it will again do this, and it will print the second one and free this. Now current pointer is our, what is our current pointer now? This 396B0. So it will free this one also. Okay, now pointer was pointer to next, so pointer should be 0 now. So it will come out of this. Okay, so this second name is also printed. This is anyway the typo, sorry, this is not compiled yet, so that's why this is coming. Okay, so let's go to further. So this just I would like to show you that demo function scope node. So let's go inside this. What's this? So this is so far we have seen that pointer to the node. Okay, and what node is our one data type. But let's say if I don't create pointers, what will happen? That it will we are not allocating right now the memory, but this use will be only just to show that struct related thing, just I wanted to demo. So don't confuse with the linked list. For linked list we definitely need that malloc. So because this is just a struct, so what it will do, it will use, where is our student, here let's create a new expression, student. Okay, so here in this particular case So this is temporary location. Okay, then student name string copy, and here the main point, we are not using the pointer, we are using dot. Okay, because this is not, this is just a not a pointer to the node, so that's why we have to use the dot. So this is one thing. Okay, now if I copy it, marks, and now you can see from here that this is the temporary location. Okay. Okay, so oh, this is again same mistake, copy paste issue. Okay, so I next time probably I need to move this as well. Okay, we have seen this debugging and all that. So this singly linked list can be used. You can think of, for example, stack. Last time we have seen the C overhead using stack kind of thing, where we have you know this last in and first output, last in and first output, and in the queue first in first output, and queue kind of structure you can think of like memory heap, like memory allocate malloc. So there doubly linked list kind of thing can be used, because any memory, as we have done free from middle of that, but suppose linked list, so that it will it can easily remove the node, or no, no, either way, means that doubly linked list is better for traversing for traversal in that particular case. Okay, so it, because in that case it can move to both the sides. Another thing you might have noticed, that demo function is in the last, it means after main. So that's why if it is not before main, we have to define the prototype in the beginning of function prototype. Otherwise, problem with the linker. Okay. So thanks for watching this. Please don't forget to subscribe this channel and provide your valuable feedback uh, to our email ID embeddedcarriers.ind@gmail.com. Thanks a lot.